All right, guys, so this is lesson 6.4, dividing monomials, which is also using the quotient rule for exponents. So, as you can see on here in our notes, we're dividing the coefficients, but we're going to actually subtract our exponents. Please remember yesterday or in the previous lesson, we learned about the power of a quotient and the zero exponent rule. We're going to be using both of those today. If you're not familiar with them or you've forgotten how to use them, you can see the previous video for more information about that. All right, so I'm going to show us again multiple forms how to do this. It is up to you what you want to use. So I'm going to show you the expanded form for number 1. Now remember, whenever we have a variable 2 raised to a power, that is telling us how many times we're multiplying that variable by itself. Same goes for if we have numbers raised to a power. That's how many times we're multiplying whatever it is by itself. So I've got x to the 5th on top, so I have 1, 2, 3, 4, 5 x's on top. I have x to the 3rd on bottom, so I have 1, 2, 3 x's on bottom. Now, anything over itself equals 1. So I'm going to go ahead and say that I'm going to separate this into x over x, and that is one set. Another x over x, again, these cancel out, and the third. All three of those are a value of 1 because it is x divided by itself. What we're left with is we're left with 2 x's, so x to the 2nd power. Excellent. Again, when we get to the bigger numbers, that might not be a feature you would like to do. So you can try something else. Instead, we can look at subtracting our exponents. So over here on 2, I've got k, I've got k to the 8th. Now, as we saw on our notes, we are subtracting. So I'm going to put 8 minus 3. Well, that simplifies to k to the 5th power. Excellent. So sometimes you're going to come across problems where something completely zeroes out. I mentioned that anything divided by itself is 1. So that is one reason for why m to the 3rd divided by m to the 3rd is 1. Another reason is because when I write it out the other way, where I do 3 minus 3, I get m to the 0. Well, previously we learned that anything raised to the 0 power equals 1. So that is 2 reasons for why this is 1. Now we're going to look at when we add more than one variable. So I've got a to the 6th, b to the 4th, divided by a squared, b cubed. So here's what I would like to look at. I want to make sure that I am only paying attention to my a's when I am doing my subtracting. I do not want to accidentally subtract a b from an a. They're not like terms. They have to be the same variable in order for me to subtract them. So I've got a 6 minus 2, but for b, I've got b 4 minus 3. Now please keep in mind, you are always using the top number for your first number and you're subtracting the bottom number from your top number. Keep that in mind for when things get trickier later. Let's go ahead and simplify this though. I cannot leave it like this. It is a to the 4th power, and it is b to the 1st power. But you know what? I can actually leave that alone and just leave it as b. Alrighty, so now we've got some numbers in with our variables. So with numbers, you just treat them as you would normally. So for example, I'm going to look at just 14 and 7. Well, 14 divided by 7 is 2. Alright, so next I'm going to look at just x squared over x. Well, I can look at this as x 2 minus 1. And then last but not least, I have y squared and y. So I've got y 2 minus 1. So I bring down my 2, go ahead and simplify your x. So I don't have to put a 1 there because it's an invisible 1. Same with y. I don't have to list the y, the exponent of 1. I can just leave it. And so this is our answer right here. All right, so now we got some negatives. Now please remember, a negative divided by a negative is a positive. So I've got 15 divided by 3 is positive 5. I've got x to the 6th over x to the 5th. So I've got x 6 minus 5. I've got y to the 5th and y to the 3rd. So I've got y 5 minus 3. And you know what? Z has nothing to subtract it. So I'm just going to bring z down. Excellent. So I'm going to bring 5 down. X is just x. Please make sure you're keeping your letters in alphabetical order. So I've got x, y, and z. So I've got x to the first power, so I just leave it as x. I've got y squared. And again, z is just the first power, so I leave it as z. Let's see. I'm going to look at 10 this time. So sometimes when we divide, it's not going to work out perfectly. 36 divided by 54 is actually going to end up leaving me with 2/3. And that's okay. So there's 2 ways you guys can do this. You can leave it as 2/3 and you can write your variables next to it. I'm going to show you guys that method. Or you can put all your variables on top next to the 2. I think I'm going to go ahead and go to 9, and I'm going to go back to 9 and show you how to do that method. So for example, 2/3. I've got x to the 9 minus 3, and I've got y to the 5th minus 2. Okay, so I've got 2/3, and I'm writing next to it x to the 6th, y to the 3rd. So you could leave your answer like this, or let me show you over here in 9 what else you could have done. So 4 divided by 8 is 1/2. Well, n to the 5th minus 1 leaves us with n to the 4th over 2. I don't have to rewrite my 1 in front of that n. I can just write it in a fractional form like this. We're going to get a little more complicated with 11 and 12. So remember I told you we're going to come back to the previous lesson. We've got to distribute this 2. Now please remember, anything outside of parentheses has to be distributed to everything inside of it. So this 2 is going to go not only to this x to the 5, but to this 3. So now I have 3 squared, and I've got x. And I've now got, instead of x to the 5th, I've got x to the 10th. Now, it does not distribute to the bottom. The parentheses are only around the top. So the bottom actually stays as it is. So I'm going to go ahead and put 27. And I've got x to the 3rd down here. So now that I have simplified things, oh, there's one more step. I cannot leave 3 squared like that. I need to go ahead and change it to 9. So I've got 9 over 27. And I can't forget my x's. They don't disappear. It's x to the 10, x to the 3rd. So now I can simplify. 9 divided by 27, that's going to leave me with 1/3. X to the 10 minus 3, that's going to leave me with x to the 7th. So I end up with, let me put that one on top. I end up with x to the 7 over 3. All right, so now I'm looking at 12. And again, I have to distribute to every single thing. There is an invisible 1 exponent on this 2. So I have to make sure I'm distributing that 3 to the 2 as well. So now I've got 2 to the 3rd power. So it's 3 times 1 is 2. Let's do green for A. I've got A to the 6th power because 3 times 2 is 6. And for B, I've got 12 because 3 times 4 is 12. So this is all going to be over. Again, the bottom doesn't change. 4, A to the 3rd, B to the 7th. Now I know you guys might not have your colors at home, so you can use instead, you can use the circle method. So this is where I'm going to circle everything. However, I'm not quite done. I cannot forget to go back and fix my constant. So it's, I'm sorry, my coefficient. So it's actually going to be 2 to the 3rd, which is going to be 8. So if you want to, you can just come back over here and you can erase this and you can write in 8. There we go. So now again, I'm using the circle method. So I've got 8 divided by 4, so that's 2. I've got A to the 6th minus 3, and I've got B to the 12th minus 7. Remember, you have to finish it off by simplifying all of it, so I've got 2, A to the 3rd, B to the 5th, and this is my final